Chapter 5, Oscillations Numericals. So we have first question. At what distance from the mean position is the speed of a particle performing SHM half of its maximum speed? So this is given to us in the question that we need to find the distance from the mean position. So please always remember distance means x. You are supposed to find the value of x. At what distance from the mean position means we are supposed to find the distance x is the speed of the particle performing SHM half its maximum speed and given its path length is 10 centimeter. Uh, Please remember for a path length is always equal to 2 times of amplitude. The relation for path length is 2 times of amplitude. Capital A is amplitude. So path length is always 2 times of amplitude. So a path length is given 10 centimeter. We will convert it to meter. 10 into 10 raised to minus 2. That will be equal to 2 times of amplitude. So we can solve and write amplitude will be 5 into 10 raised to minus 2 meter. So we have got amplitude from this given data. The amplitude of the particle performing SHM is 5 into 10 raised to minus 2 meter. So this is the formula. We should remember that path length is always twice the amplitude, 2 times of amplitude. The question is asking at what distance? We still need to find x is the mean from the mean position speed of the particle performing maximum speed, half of a maximum speed. So this is given to you that speed v is equal to half of v max. This is given to us in the question that the speed of a particle, that is v, performing SHM is half its maximum speed, so half of v max. We have formula for v, that is velocity or speed, that is omega root a square minus x square. So that will be equal to half v max. V max is equal to a omega. We can cancel omega from both sides. So we are left out with the root a square minus x square equal to half a. Let us square this. So we get a square minus x square equal to 1 by 4a. Let us rearrange the term and find x. So x square will be equal to a square minus 1 by 4a square on rearranging the terms. So this will be 3 by 4a square. So this will be x square, but we need x. So x will be equal to root 3 by 4 into a, right? So x square is equal to 3 by 4 a square, but we need x. So x will be equal to root 3 by 4 a square root, sorry, 3 by 2. This will be 3 by 2, 3 by 2a. So x will be equal to root 3, 1.732 upon 2 into a value. A value is this. We will substitute the value of a as this value. And when you substitute the value, you get the answer as 4.33 into 10 raised to minus 2 in meters. So we get the answer as 4.33 into 10 raised to minus 2 meters, the value of x. Next question, in SI units, the differential equation is given by, this is given to us, d square x by dt square is equal to minus 36x. Now let us compare this equation by differential equation, since in the question they have said a differential equation. So comparing with d square x upon dt square plus omega square x equal to 0. Let us compare the equation with this d square x upon dt square plus omega square x equal to 0. If I write this equation I can rewrite as d square x upon dt square. If I take this minus to left side, this will become plus. So plus 36x, this will be equal to 0. So when I compare these two equations, when we compare these two equations that are written in front of us, equation, so we see omega square is equal to 36. On comparing, I get omega square will be equal to 36. So therefore I can write omega square equal to 36, or I can say omega equal to 6 radian per second. The unit of omega is 6 radian per second. Unit of omega is radian per second. But we need to find what? We need to find the frequency and time period. So we know that omega is equal to 2 pi n. So n will be equal to omega upon 2 pi. That will be 6 upon 2 pi. That will be 6 divided by 2 into 3.14. So on solving this, we get the answer as 0.95. 0.95 hertz. So this is the frequency. Time period is inverse of frequency. So 1 upon 0.95. So this will be nearly 1.04 seconds. 1.04 or 1.05. So very simple 2 marks question. So such type of problems are expected in board exam for 2 marks. This type of numerical. You can mark it as important. This is an important problem. Mostly it asks with comparison. So here you can see they have compared with the differential equation. So such type of problems are majorly asked. Next, we have a needle of a sewing machine moves along a path of amplitude is given to us 4 centimeter, 4 into 10 raised to minus 2 meter. With the frequency is given, n is given by 5 hertz. Then time is given 1 by 30 second. The question is asking find the acceleration. Find the acceleration A 1 by 30 second after it has crossed the mean position. You have to find the acceleration 1 by 30 second after it has crossed the mean position. Now, since it has crossed the mean position, in that case, your acceleration will be equal to A will be equal to omega square A sine omega t. This is the formula when acceleration, even when you need to find the acceleration after crossing the mean position. This can be taken A equal to omega square A sine omega t. This is the formula to find the acceleration after it has crossed the mean position. So A will be equal to omega square. So omega is not given. We can write 2 pi n square into A into sine. Again, omega can be written as 2 pi n into t. So A will be equal to 2 into, sorry, this will be 4. If I open the brackets and just square this term, so this term will become 4. 4 pi square into n square A sine 2 pi nt n into t. Now let us put the value. A is equal to 4 into, always remember pi square is 9.8. So let us directly substitute 9.8 into n square. N is 5. So 5 square 25 into capital A. Capital A is 4 into 10 raised to minus 2 into sine 2 into 3.14 into 5 into t is 1 by 30. So this is our relation. So when you solve this, on solving this, you get the answer as 39 34. You will get the answer as 34.2 meter per second square. Sometimes you can also neglect this sine omega t term and solve. In that case, your answer will change. It will be 39 something. So, but we can use this relation also. So we can use this formula. So you will get the answer as 34.2, which is matching with the textbook. If you don't consider sine omega t term, you get the answer as 39 point something. So that answer doesn't match with the textbook. But if you want your answer to be matched with textbook, so this will be the formula. Potential energy of a particle performing linear SHM is given. So potential energy is given 0.1 pi square x square joules. If mass of the particle is 20 gram, so 20 into 10 raised to minus 3 kg, find the frequency n you are supposed to find. So potential energy is given, so we will use potential energy formula half k x square. We know this is the formula for potential energy. In LHS, we will substitute the value of potential energy, that is 0.1 pi square x square, that is equal to half. Instead of k can be written as m omega square. We can write k can be written as m omega square, and omega can be written as 2 pi n. And when I open this, I can write m 4 pi square n square equal to k. So instead of small k, I can write this term also. That is m 4 pi square n square. I've squared the term. So instead of k, we will substitute this term because I need to find frequency. So frequency, I will get it from here only. So I will write it as m 4 pi square n square into x square. So if you see, x square and pi square will get cancelled. Now just substitute the value. So you get 0.1. I can write 0.1 as 10 raised to minus 1 equal to 1 by 2 into mass is given 20 gram, 20 into 10 raised to minus 3 into 4 into n square. So I can write n square equal to, this will become 10. 10 into 10 raised to minus 3. Okay. So I can write this as 10 into 10 raised to minus 3 will be 10 raised to minus 2. So minus 2, if it goes up, will become plus 2. So n square equal to 10 raised to 2 minus 1. 10 raised to 2 minus 1 is 10 raised to 1. So therefore n square equal to root 10. So if you take the root 10 value, you get something nearly, the answer is 1.5. Okay, yeah, there is a mistake here. There's a mistake here. I have not taken that 4. 4 is to be considered. So here in the denominator, I will have to take 4. Yeah, in denominator, I have missed the 4. So here this will be 4 into 10 raised to minus 2. So the calculation will be different. So here this will be n square will be equal to 1 by 4 into 10 raised to 2 will go up and it will become 10 raised to plus 2. 2 minus 1 is 1. So that is 10. So 10 by 4. 10 by 4 is 5 by 2. So n will be equal to 5 by 2 means root 2.5. 5 by 2 is 2.5. So n equal to root 2.5. 2.5 is 1.25 hertz. Root 1.25 hertz. That will be your sorry, root 1.58. 1.58 will be your answer. Next, the total energy of a particle performing SHM has 2 kg mass. This is given that mass is 2 kg. The total energy is given as 40 joules. Find the speed while crossing the center of the path. We need to find the speed while crossing the center of the path. So we know total energy is equal to half k a square. Now at the center, this is very important. At the center, velocity is maximum. So at the center, v is equal to v max. That is given by omega a, right? So what can I do? I can reopen this formula. I can again open k. So I can write total energy will be equal to half into, as we have done back. So here, as we have opened this k equal to m omega square, we'll do it again here. So this will be m omega square a square. I've opened the k value, and see, if you see here, that is omega square into a square. So as I told, v max is omega a, right? So I can write, if v max is omega a, so omega square a square will be equal to v square max. So I can rewrite this as half m v square max, right? So just rearrange now. So we need v max, v or v max, whatever. So v will be equal to, so if I rearrange this, so 2 into total energy, 2 into total energy upon mass. Rearrange the formula. So v max will be equal to root 2 into total energy given is 40, and this is 2. So again 2 to cancel. So v max will be equal to root 40. Root 40 will be nearly 6 point something. If you see, it will be 6.32 something meter per second. So this is the formula for, this is the value for Vmax. A simple pendulum of SHM time period is given 4 seconds. How much time after crossing from the mean position will the displacement of the bob, displacement is x, will be 1 by 3 of amplitude. So this is given. How much time they are asking? So t, small t, I am supposed to find. Always remember, capital T is the time period, small t is the time taken. So how much time it has been asked? So in this case, what we will do here, we will use the equation for displacement. We'll use the equation for displacement. We have x equal to a sine omega t. For mean position, we have displacement x equal to a sine omega t. I can write x is 1 by 3a. This is equal to a sine. Omega can be written as 2 pi by t into t. So this a getting cancelled. So 1 by 3 sine, 1 by 3 equal to sine 2 pi by 4 into small t. 1 by 3 is 0.33. So I can write this as 0.333. That is equal to sine. This I can cancel. 2 ones are 2 twos are. So this will become sine pi by 2t. Pi by 2t is together, sine term. Take sine on that side. So it will become sine inverse 0.333 equal to pi by 2t. Sine inverse 0.3 value you can take from your logbook. From your logbook, when you find this value, this will be 19 degree 30 minutes. So this will be pi by 2 into t. Now since over here there is pi, so we need to convert it to radian. So just convert this 19 degree into 30 minutes to radian. So you will get this as 19.5. So this will be 19.5 into, this will be 180. This will be pi by 180. When you convert it to radians, this will be pi by 180. 19 degree 30 minutes can be written as 19.5. When you convert it to radian, this will be coming as pi by 180 equal to pi by 2t. So pi getting cancelled. So when you solve this, you get the answer for t. Just solve this equation, you get the answer for t, and that will be equal to 0.21, nearly 0.21 seconds. And that will be your answer. Next sum, a simple pendulum of length is given to us. A simple pendulum length is given to us. 100 centimeter performs SHM. So length is given as 100 centimeter. 100 centimeter can be written as 1 meter. Performs SHM. Find the restoring force acting on the bob of mass 50 gram. So mass is given 50 grams. So convert gram to kg. 50 into 10 raised to minus 3 kg. When the displacement from the mean position is 3 centimeters. So displacement is given 3 centimeter, 3 into 10 raised to minus 2 meter. So restoring force F is equal to, in case of simple pendulum, the restoring force is equal to mgx upon L. This is the formula from the derivation that we have got. The restoring force in case of simple pendulum is given by mgx upon L. So just substitute the value. So F will be equal to 50 into 10 raised to minus 3 into g value 9.8 into x value is 3 into 10 raised to minus 2 divided by L is 1. So when you solve this, you will get your answer. So the answer for this question is 1.48 into 10 raised to minus 2 Newton. Next, some find the change in length of a second's pendulum if the acceleration due to gravity is at a place changes from 9.75 to 9.8. So we need to find the change in length. So change in length, I can say final length minus initial length. Change in length, that is delta L, can be written as L2 minus L1. L2 minus L1, final length minus initial length. So L2, so in case of a seconds pendulum, for seconds pendulum, we have relation between length. For seconds pendulum, we have a relation between length and acceleration due to gravity, and the formula is L equal to pi square upon g. For seconds pendulum, L equal to pi square upon g. So I can write L1 equal to pi square upon g1, and L2 can be written as, oh, I'm sorry, this is g by pi square. This is g by pi square. The formula is g by pi square. So this will be equal to g by pi square. G1 by pi square and G2 by pi square. G by pi square. So L1 will be equal to G1 by pi square and L2 will be equal to G2 upon pi square. So change in length delta L is equal to L2 minus L1, that is G1 by pi square minus G2 by pi square, and G1 value is given as the first value, that is 9. G2 minus G1, G2 minus G1, so that will be 9.8 minus 9.75. I can take pi square common in the denominator. So on solving this, you get the answer as 0.0051, 0.0051 meter. At what distance from the mean position? This is a very important question. At what distance from the mean position, again X is been asked, is the kinetic energy of the particle performing an SHM of amplitude 8 centimeters, 3 times the potential. 3 times the potential. In given, they have given that amplitude is 8 centimeter. So kinetic energy formula half k a square minus x square equal to 3 into potential energy half k x square. So I can cancel half k from both sides. I get a square minus x square equal to 3x square. Taking x square together, so I get a square equal to 4x square. So therefore I can say x equal to a by 2. Taking square root, I can write x equal to a by 2. A is 8, so 8 upon 2, that is 4 centimeter. It is 4 into 10 raised to minus 2. Many times these type of sums are repeated in board exam. A particle performing a linear SHM of period 2 pi seconds. So time period is given 2 pi seconds. About the mean position, O is observed to have a speed V is given. Speed is given B root 3 meter per second when it is at a distance B from O. Now for this case, we will have to draw the diagram. The diagram is not mentioned in the question. So if I consider some mean positions, suppose O is my mean position, and okay, I can take then any letters. So O is mean position. This is A. This is suppose B. So the question is telling if O is the mean position. Please understand carefully. If O is the mean position, then there is a speed which is given to us. Speed V equal to B root 3 when at a distance B from O. Speed at this point. Suppose if this distance is B, this distance is also B. The total distance will be 2B. Now I have taken these two distances. You will get to know if you read the further question. I'll read the entire question first. When at a distance B from O, when at a distance B from O, the speed is B root 3. When it is at a distance B from O, that means I have been given speed at A is equal to B root 3. I have been given the speed at A is equal to B root 3. because point A is at B distance from O. Our question is telling the speed is B root 3. The speed is B root 3 when it is at a distance of B meter from O. Now, if the particle is moving away from O at that instant, find the time required by the particle to travel a further distance B. मतलब जो A पे डिस्टेंस था उससे और आगे B डिस्टेंस लेना है. सो दैट डिस्टेंस विल बी B. दैट्स व्हाई आई हैव टेकन टू डिस्टेंसेस. ठीक है, A के आगे और B डिस्टेंस. If you consider one more B distance, so it will be point B. So what is the time required to be reaching at point B? I will explain once again. The question is asking a particle performing linear SHM has time period 2 pi seconds. The speed at some point which is at B distance. So I have taken that point as A, which is at B distance, small b distance from O is B root 3. Now I need to find the time when it reaches further distance of B. You need to find the time required by the particle to travel further distance. Further from where? Further from A. So from A, I have taken one more B distance at point B. So the total distance from O to B will be 2B, right? Now we know that this is the mean position. This is called as a mean position, and this is called as an extreme position because the particle will end its journey at B, right? Capital B. So that will be the extreme position. So we know that between mean and extreme position, that this is called as an amplitude. So I can say 2B is the amplitude. So amplitude is given as 2B. मीन पोजीशन एंड एक्सट्रीम पोजीशन के बीच में जो डिस्टेंस होता है दैट इज कॉल्ड एज एन एम्पलीट्यूड, राइट? सो ए इक्वल टू 2b. So my amplitude will be equal to 2b. That is my amplitude which I have got from here. Now to find this time t, since it is crossed the mean position, after crossing the mean position, the velocity will be after crossing the mean position. V will be equal to, the formula will be omega A cos omega t. This will be the formula because it has crossed the mean position. So V will be equal to omega A cos omega t. Now students, please remember one thing that we have written over here. The time which it is required to find will be taken out from this equation, V equal to omega A cos omega t. So we can write from here that V is given as B root 3. So B root 3 equal to omega can be written as 2 pi by t. Amplitude is 2b into cos 2 pi by t into small t. So when you substitute the value, so you see this b getting cancelled. So when you substitute the value, you will get root 3 equal to 2 pi upon time period is also 2 pi into 2 cos 2 pi upon 2 pi into t. So this will get cancelled 1. This will get cancelled 1. So take this 2 to this side. This will become root 3 by 2 equal to cos t. So therefore t will be equal to cos inverse root 3 by 2. So in which angle do we get root 3 by 2? In case of cos, we get root 3 by 2 at pi by 6, right? So time taken will be pi by 6. Lekin this time taken will be pi by 6 from O to A. This I have not solved till B. This is for O to A. From O to A, because B root 3 velocity कहाँ पे है? A point पे है ना? So I have just found out time taken from O to A, right? So time taken from O to A will be pi by 6. So what will be the time taken till B? Further distance पता करना है ना? It will be double of this time. Always students, please remember, whenever such type of question is asked, the time will be double of this time. Please remember, from mean to extreme position, if I say from mean to extreme position, this point A is half of mean position, half of extreme position, right? This is A by 2. I can say this is half of amplitude, right? So from going from O to half of amplitude, that is A, the time taken is pi by 6. Then going from A to B, it will be 2 times of pi by 6. So time taken to reach B, therefore time at B will be equal to 2 pi by 6. So 2 pi by 6 is pi by 3 seconds. So this will be our answer. I repeat once again, time taken to go from mean position to extreme position, right? But in between, there was half of amplitude at point A. Point A, I can say it is half of amplitude. Time taken from O to A is pi by 6. So time taken from A to B will be double of that. So that will be pi by 3. 2 pi by 6, that will be pi by 3. Next. A period of oscillation of a body of mass m1 is suspended, a light spring is T. So let us consider a block which is suspended to some say a body of block mass m1. Suppose time is t. I have one more body similarly, which is suspended, and time is given as 2t. But here one condition is given. This is m1 with m2. This is m1 with m2. There are two blocks now. The entire system has two blocks, and the two blocks has time period 2t. When there was one body, the time period was t. When there are two blocks, m1 and m2 both together, then the time period is 2t. Okay. Now compare the masses m1 and m2. So I need to find the ratio of m1 upon m2. So we know that t is proportional to root m. This is our formula. Time period is directly proportional to root m. So I can say t1 upon t2. This will be, I can taking as t1. This I will take it as t2. So t1 upon t2 will be equal to root m1 divided by root m1 for first mass. For second case, I will write both together, m1 plus m2. Why? Because दोनों mass मिलके time 2t हो रहा है ना. So I will have to consider both masses. I will not consider one mass. Both blocks मिलके time 2t हो रहा है. So I will have to take both blocks. So just substitute the value 2 t upon 2t equal to root m1 upon m1 plus m2. So just square this. Pt cancel. So this will become 1 by 4 when you square, and this will be equal to m1 upon m1 plus m2. Just cross multiply the terms. So you get m1 plus m2 equal to 4m1. Take m1 to this side. So m2 will be equal to 3m1. So m2 upon m1 is 3, but I need m1 upon m2. So m1 upon m2 will be 1 by 3. This will be our answer. The displacement of an oscillating particle is given by x equal to a sine omega t. So this is given to us. The given is x equal to a sine omega t plus b cos omega t. And we need to prove that the total resultant amplitude is root a square plus b square. So let us prove this. So this is a proof type numerical. So let us see. So we have been given from equation that x equal to a sine omega t plus b cos omega t. But we have displacement. Formula is a sine omega t plus phi. Displacement formula is a sine omega t plus phi, right? So I'll give this as equation 1. I'll give this as equation 2. The equation 1 is the given equation x equal to a sine omega t plus b cos omega t. And I need to find the resultant amplitude. But we have been given that x equal to a sine omega t plus phi. This is given to us. I'll equate 1 and 2. Equate 1 and 2. So I get a sine omega t plus phi, which is our formula for displacement, will be equal to a sine omega t plus b cos omega t. So just open this bracket on the LHS, the LHS part of the bracket, you will open it using sine a plus b. So in this term will be opened by use sine a plus b, the expansion formula for this bracket. So we get this as a sine a cos b plus cos a sine b, that is equal to a sine omega t plus b cos omega t as it is. Multiply a inside. So I can write a sine omega t cos phi plus a cos omega t sine phi. Take these both terms to right hand side. So this will become minus a sine omega t. Take these both terms to left hand side. So this will become minus b cos omega t equal to 0. So in the right hand side, we will have 0. Now what do you see? There are two terms which has sine omega t in common. There are two terms in the equation which have sine omega t common, this one and this one. And this term has a cos omega t in common. So let us take that terms common. So from one side we will take sine omega t, from the other side we will take cos omega t common. So we will take here sine omega t common. So inside we are left out with a cos phi minus a plus cos omega t common. So we are left out with a sine phi minus b equal to 0. To satisfy this equation, to satisfy LHS equal to RHS, this equation will only be satisfied when I take the bracket terms will equal to 0. The above equation will be satisfied when the bracket terms are taken as 0. So let us put these bracket terms as 0. If I put bracket terms as 0, so I get LHS equal to RHS, right? If I put that bracket terms 0, so 0 into sine omega t, 0. 0 into cos omega t, 0. 0 plus 0 will be equal to 0. That means LHS and RHS are satisfied. So I can write a cos phi minus a equal to 0 and a sin phi minus b equal to 0. Take minus a and minus b to the other side. You get a cos phi equal to a and a sin phi equal to b. Give it as equation 3 and 4. Just square and add equation 3 and 4. Let us square and add equation 3 and 4. So we get a square cos square phi plus a square sin square phi equal to a square plus b square. If I take a square common, inside I am left out with a square common. When I take a square common, inside I am left out with cos square phi plus sin square phi. So cos square phi plus sin square phi is 1. So that is equal to a square plus b square. So take square at that side. So I can say a equal to under root of a square plus b square. This is what I was supposed to prove. A equal to root a square plus b square. Two parallel SHM are represented by two equations. So we have equation x equal to x1 equal to a1 sine omega t plus phi 1. When there are two SHMs, we know that there are two equations, and x2 equal to a2 sine omega t plus phi 2. Right? So I can compare this equation with x1 equal to given equation x1 equal to 5 sine 4 pi t plus pi by 3 in centimeters, and I can compare this equation with x2 equal to 3 sine 4 pi t plus pi by 6 in centimeters. So I get, what do we get? So we get a1 equal to 5, a2 equal to 3, omega is common in both, that is 4 pi, phi 1 is pi by 3, and phi 2 is pi by 6. This is what the given I can get when I compare the two equations. x1 equal to a1 sine omega t plus phi 1, x2 equal to a2 sine omega t plus phi 2. I'm comparing it with both the equations. Okay. The question is telling they both are superposed. When they both are superposed in a particle, they determine the amplitude and epoch. Now resultant amplitude A is equal to root of a1 square plus a2 square plus 2a1 a2 cos phi 1 minus phi 2. This is our formula. So when you put this value, you get root a1 square, that is 5 square plus 3 square plus 2 into 5 into 3 into cos. When you substitute here pi by 3 and pi by 6, so you get pi by 3 minus pi by 6. You cross multiply by that, pi by 3 minus pi by 6. So pi by 3 minus pi by 6 is in radian. When you put the value for phi 1, that is pi by 3, and phi 2, that is pi by 6. So you solve that, you get, you when you cross multiply, you get 3 pi by 18, that is pi by 12. You will get that pi by 12. So this value is whichever you will get over here. This will be 15 degree. When you convert it to degree, this value after solving will be in degrees. When you convert, it will be 15 degree. I'll just solve it over here in the rough. So pi by 3 minus pi by 6. So this will be 6 pi minus 3 pi, that is 3 pi by 18. So this will be, sorry, so this will be pi by 6. Okay, this is pi by 4. This is pi, I'm sorry, this is my mistake. This is pi by 4. This is not pi by 6. In x2, it is pi by 4. I misruled as pi by 6. So this will be pi by 4 over here. I have written wrong value. Pi by 4, pi by 4. So yeah, when you cross multiply this, you get pi by 12. So pi by 12 is 15 degree. So cos 15. So just substitute the value and just solve. You get this answer as 7.936 centimeter. So when you solve this, you get A equal to 7.936 centimeter. For epoch, we have the formula tan inverse a1 sine phi 1 plus a2 sine phi 2 divided by a1 cos phi 1 plus A2 cos phi 2. This is our formula. Now this is a lengthy calculation, so I'm not expecting you, don't, please don't expect me to solve here. It is up to you to solve. You have to just simply put the value. I've told you the formula. Simply put the value A1 sin phi 1, A1 value, sin phi 1 value, and phi 2 value. When you solve that, you get the given answer. That's 54 degree. You'll get something around 54 degree, approximately 54 degree, 29 minutes. Nearly this answer you will be getting. So calculation is for the students to do. You will have to make your calculation strong and just practice. A 20 centimeter wide thin circular disc. 20 centimeter wide means diameter is given. Diameter is 20 centimeter. So radius will be 10 centimeter. I'll convert this 10 centimeter, 10 into 10 raised to minus 2 meter. Mass is given 200 gram. I can write it as 0.2 kg. Is suspended through a rigid support from a thin metallic string. By holding the rim of the disc, the string is twisted through 60 degree. So theta is given 60 degree, right? 60 degree and released. It now performs 60 degree. I can make it in radian. That is pi by 2. And performs angular oscillations of period of 1 second. Time period is given 1 second. Find the torque acting on it. Now, since it is performing an angular acceleration, sorry, angular oscillation, in this case, we will have to take tau equal to c theta. In this case, we have tau equal to c theta. Then what is c? From differential equation of linear SHM, we will have to find out the value of c from differential equation of linear SHM. So from differential equation of angular SHM, we have the c value, which when you solve, you get the value for c as I into omega square. So tau will be equal to I omega square into theta. So tau will be equal to, for the disk, we have moment of inertia mr square by 2 into omega square theta. So now you will have to substitute the value to solve for torque. So torque will be equal to 0.2 into r square, that is 10 into 10 raised to minus 2 square upon 2 into omega square. Omega can be written as 2 pi by t, the whole square, into theta, that is pi by 3. So when you substitute the value, you get your answer in Newton meter. So just solve this, you get the answer. The answer will be nearly 0.4 something, 0.041. Yeah, the answer is 0.041. So it is for the students to do the calculation and solve. You get this answer. Find the number of oscillations performed per minute by a magnet vibrating in a plane of uniform magnetic field is given. B is given 1.6 into 10 raised to minus 5 Weber per meter square. Magnet has moment of inertia I 3 into 10 raised to minus 6 kg meter square, and magnetic moment mu is given as 3 ampere meter square. Find the number of oscillations means frequency. Number of oscillations is frequency n. So we know that time period is 2 pi root I by mu b. This is our formula. Time period for a bar magnet rotating in a uniform magnetic field, torque is equal to 2 pi root I by mu b. So find the time period and take the inverse to get the, or you can say n equal to 1 by 2 pi root mu b upon I. Even that can be done. Just take the inverse here only. So just substitute the value, and whatever answer you will get, that will be in seconds, because that will be in SI unit, that will be in second. So you have to multiply by 60 to get it in minutes. You have to multiply by 60. Okay. So just multiply by 60 to get it in minutes. So whatever answer you get over here, answer multiplied by 60 will give you the correct answer. So that will be 39 point something. Yeah, 38 point something is the answer. Approximately 38 point something is the answer. A wooden block of mass m is kept on a piston that can perform vertical vibrations of adjustable frequency and amplitude. So during the vibrations, we don't want the block to leave the contact with the piston. How much maximum frequency is possible when if the amplitude of the vibrations is restricted to 25 centimeters? So the first data we have is amplitude is 25 centimeter. It is 25 into 10 raised to minus 2 meter. This is given to us. And in this case, how much is the energy per unit mass of the block? So first, let us find the frequency. And so in this case, they don't want the block to leave the contact with the piston. So for this case, the restoring force should be equal to the weight. Restoring force is Kx, that should be equal to weight of the block, that is equal to mg. So Kx, but x is the displacement and maximum displacement. During vibrations, it is making maximum displacement. Maximum displacement is amplitude. So Ka equal to mg. So from here we have Ka equal to mg. We need to find the value of n, that is a frequency. So from here, how do we find the value of frequency? Because here one thing they have given, During vibrations, we don't want the block to leave the contact with the piston. How much maximum frequency is possible if the amplitude is given as 25 centimeters? So from here I can write Ka equal to mg, and K can be written as m omega square. So m omega square equal to mg. M omega square into A is equal to mg. Cancel. Omega square equal to g upon A, or I can say omega, instead of omega I can write omega equal to 2 pi n, since I need frequency. So I can just simply substitute over here 4 pi n and solve. So when you put here 4 pi 2 pi n, 2 pi n the whole square equal to g by A. So I get this is 4 pi square n square equal to g by A. So therefore n square will be equal to g upon A 4 pi square. So as I told, g and pi square will get cancelled because they are same. So this is 1 upon A4. So uska root le lo, take the root value, you get the value of frequency. What is the energy per unit mass of the block? To find the energy per unit mass of the block, that is the second case that they are taking. Energy per unit mass is equal to half omega square A square. That is your formula. Energy per unit mass is equal to half omega square A square. So again, just put the value and get the answer. That will be your final answer. So answer will be 1.25 joule per kg. That will be your answer. So this much was for the oscillations chapter.